Example 5, repeat example 4 with the loads connected in delta instead of Y. So now we are going to have a Y-delta system. And since it's a Y-delta system, this means that V phase equals V line and I phase equals I line divided by the square root of 3. So we're going to make a couple of assumptions. Once again, we're going to assume that 208 volts is our line voltage. So VL equals V phase, which equals 208 volts. And we are going to assume that our line voltage, since we have a delta connected load, is our reference. So we're going to have VAB equals 208 with an angle of 0 degrees, and that is our reference. Then VBC is equal to 208 with an angle of negative 120 degrees. And VCA is equal to 208 with an angle of 120 degrees. Now we are going to find our phase voltage. So our phase voltage is going to be found by using VAB over Z phi. So that's going to be 208 with an angle of 0 degrees over 120 with an angle of 35 degrees. That's our phase current. So it's 1.733 with an angle of negative 35 degrees. So then we'll delay the other two, and this one is IAA, IAB. And so then we're going to have IBC is equal to 1.733 with an angle of negative 155 degrees. And ICA is equal to 1.733 with an angle of positive 85 degrees. So now to find the line currents, we're going to use the relationship that IL equals the square root of 3 angle negative 30 degrees times I phase. So IA would be equal to the square root of 3 angle negative 30 degrees times IAB, which is 3 with an angle of negative 65 degrees, and the units are amps. So then you delay it by 120. So IB is 3 with an angle of negative 185 degrees, and the units are amps. And IC is 3 with an angle of 55 degrees, and the units are amps. So there's our phase voltage, line voltage, phase current, and line current. So next we want to find the real, reactive, and apparent power delivered to the load. So first we're going to find the real power. So power 3 phase is going to be equal to the square root of 3 VL IL cosine of theta V minus theta I. So this is going to be the square root of 3 times 208 times 3 times the cosine of 35 degrees, which is 885.3 watts. Then the reactive power, Q3 phase, is the square root of 3 VL IL sine of theta V minus theta I, which is equal to the square root of 3 208 times 3 times the sine of 35 degrees, which equals 619.9 var. And then for the apparent power, which is the magnitude of the complex power, we know that we can use either the square root of P 3 phase squared plus Q 3 phase squared, or we can use the square root of 3 VL times IL, and that is 1080.8 volt amperes.